Alright, so I'm going to run through the final exam from last year. The final was given, and most of the problems that we see on this exam are going to be very similar to what we have upcoming for our exam. I will say that this exam is a bit easier than what we covered this year. So the first section is the word bank, simply matching vocabulary. I'm not going to go through these, so these are on your answer key. If you have any questions, though, feel free to ask me about them. All the way to identifying parts of triangles, and then these are real important. Make sure you know all four of these. They come up a lot, and they are bound to be on your final. Alright, so I'm just going to do one question at a time. It may get a bit crowded. If it does, I'll try and clear it out and move on as quickly as possible. So number 36, what is the intersection of plane WYZ and plane HFX? Well, let's highlight those. WYZ, a plane, remember, is like a sheet of paper, so that's the bottom of mine. And HFX is going to be this side on the corner. Where do those intersect? Well, they intersect right along this line. That line is ZX or XZ, so my correct answer is C. Number 37, using the picture from the question above, which lines are skew? Remember that skew means that they don't intersect, but they also cannot be in the same plane. So let's just go down the list and see which ones we can eliminate. Let me clear this up. WY and HF. Here's WY, HF. Notice that they're going in the same direction, so therefore those are not skew, those are actually parallel. So we'll P for parallel. WX and YZ. WX goes this way, YZ goes this way. Notice that once again they go the same direction, so those are parallel. GY and HF. Here's GY, and here's HF. Notice that those two will never intersect each other, and yet they don't go in different directions. So this is my skew lines. Let's just check the rest of them just to make sure. ZY and XZ. Those are going to actually hit at point Z. Here's ZY and XZ. Those are going to hit right there at point Z. And the last one, HG and WX. HG, WX. Notice that they're going in the same direction, so therefore those are also parallel. Number 38. If MN is equal to 4 and MP is equal to 12, be careful. Make sure you label it correctly. MN is 4. MP is the entire segment, which is 12. This is simply the segment addition postulate, or the part plus the part equals the whole. So we have the 4 plus x must equal 12. So therefore, if we solve it, we do minus 4 on both sides. They cancel out, we get x equals 8. And our answer is
Marcus
A.
Little and Mia Stansel, please come to the ministry office at this time. Marcus Little and...
Alright, we'll move down to number 39 here. Slightly harder, but same idea, same principle. Let point X be between point P and point Q. So let's draw a line. Here's point P. Here's point Q. Put X anywhere between it. It really doesn't matter. Let's just put it there. It tells us that PQ is equal to 3y minus 1. So that is the entire segment. 3y minus 1. It says that XQ is 2y. And it says that PX is 10. It's the same concept as the last problem. It's that the part plus the part equals the entire thing. So the part is 10 plus 2y. Part plus part equals the whole. Well, the whole is 3y minus 1. Once you set up your equation, it's simply algebra. So we'll subtract 2y from both sides. These will cancel. We get 10 equals y minus 1. We then add 1.
Kimberly James, please come to the main office. Kimberly James, please come to the main office. Thank you.
We then add 1 to both sides. These cancel, and we get y equals 11. Go over to our answer choice. B is your correct answer. Please be sure that you're answering the question that is asked. Here it says find y, so we found 11. If it asks you to plug it back in, please be very careful. Number 40, for a parallelogram. It's very important. Find the value of x. Well, for a parallelogram, we know that the angles that are consecutive are also supplementary. And supplementary means that they add up to 180 degrees. So this one's pretty easy. You say 50x plus 130x equals 180. 50 plus 130 is 180. X equals 180. Divide both sides. We get x equals 1. Check your answers. C. Last one is number 41. If the circumference of a circle is 8 pi feet, please be sure that you remember this 8 pi. A lot of students forget the pi part. So 8 pi feet, what is the area? Well, the formula for the circumference is 2 pi r. Remember that on the exam, you will be given a formula sheet. I've given you a copy of that, but if you have any questions, please let me know. Plug in your circumference into the c value, so 8 pi equals 2 pi r. Divide both sides by 2 pi. 2's cancel, pi's cancel. Pi's cancel out over here. 8 divided by 2 is 4, equals, the only thing that's left is r. Now, we're not done yet because it asks for the area. So we need to take this radius and plug it into the area formula. The area of a circle is pi r squared. So the area is equal to pi times 4 squared. 4 squared is 16. So the area is 16 pi. Don't forget your units. It's an area, so it's going to be something squared. We check back. It was feet to begin with, so it's going to be feet squared. Forward to our answers. 16 pi feet squared. Number 42. At most, how many common tangents can the two circles share? A common tangent, common means more than one, so it hits more than one circle. Tangent is it hits only once, so it's a line that intersects only once. That hits the circle once. For our situation here, there are actually 3 possibilities. Most students will come up with 2. It's here. There's 1. There is 2. And the third one goes right through the middle. Okay, not drawn perfectly, but there are 3 possible options, so our answer is D, 3. 43 talks about logic from a long time ago, chapter 2. If point B is the midpoint of AC, then point B bisects AC. If point B bisects AC, then AB is equal to BC. Using the law of syllogism, what conclusion can be drawn? The law of syllogism, remember, says that if A then B, if B then C, so therefore, if I start with A, I'm going to end up with C. If we notice what we have here, notice that point B bisects AC is repeated. That's my B part. Notice how it's repeated at the end of the first part and the beginning of the second part. So then we need to pick only the A part and the C part out. Well, my A part is if point B is the midpoint of AC. Notice that shows up right here. And my C portion is the last part, which is AB is congruent to BC. That shows up here. So my correct answer is A for number 43. Scrolling down just a little bit to number 44. To prove that KLM is congruent to KLN, which triangle congruence postulate can we use? Remember, we had 5 of them. They're all listed there. Oh, no, they're not. Excuse me. Oh, correct, they are. All 5 of them are listed there. Angle, angle, side, 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 angle, and hypotenuse, leg. Remember that this is only for right triangles. If you look at what we've been provided with one angle here and one angle here. So right away we know we're going to have 2 angles. So that's going to kill these 2. There's no right angle, so that's not going to work. The last question is my side in between them, or is it outside of the 2 angles? Well, if we take a look, remember I taught many of you to look for shared sides in bow ties. Here's the shared side. Notice that LK is both part of the lower triangle and the upper triangle. It is in the middle, which means that it is included. It's an included side. So therefore, we write it just like that. It's A, and the S goes right in the middle because it does on the picture as well. So our answer is D, angle side angle. Number 45 and 46 refer to the figure. Name an angle that is supplementary. This means adds up to 180. Supplementary to LRQ. LRQ is right here. There are two possible options for the ones that would be supplementary. One version would be right here. Notice that together the red and the green one make a straight line. The other option would be up here. Notice that together you have the straight line here or the straight line here. So let's check our answer choices. We're either looking for LR, sorry, I should do that in blue. A second. We're either looking for LRN or we're looking for Q. That should be green. My bad. We're looking for QRP. Coming over to our answer choices. MRN, nope. LRM, very close, but nope. NRP, very close, nope. PRQ, well, kind of. MRP, no. PRQ is the exact same thing as this, except it's written backwards. PRQ. Remember that it doesn't matter how I order them. As long as the vertex is in the middle, notice that it's R for both of these, it will be the same angle. So PRQ is the same as QRP. So the answer is D. Let me get a new page because I got messy. Name an angle that is vertical to LRQ. We're still talking about LRQ. Vertical, remember, this angle is vertical with this one. This obtuse angle is vertical with this obtuse angle. All vertical angles are always congruent or equal. So if we're looking at LRQ, we're going to find the one that's directly across from it. The one that's directly across from it is right here. We're looking for either NRP, angle NRP, or angle PRN. Those are going to be the same. Notice that the vertex is still R. So go through your choices, and the correct answer is your last one, choice E. Number 47, a gimme question. If angle 1 is 83 degrees, is it acute, right, obtuse, or straight? Remember that acute means anything less than 90, so the answer is A. Another gimme for 48. The sum of the measures of the interior, so we're talking about the inside of a triangle, angles 1, 2, and 3. For every triangle, they add up to 180 degrees. If points A, B, and C are the midpoints of their sides, midpoints means it cuts it into two equal parts. So right away we can mark them. A is going to divide this piece into two equal parts. B is going to divide EF into two equal parts. And C is going to divide DF into two equal parts. Notice that those are all not necessarily the same, so that's why I have to mark them with the different measures. The line segments inside are called mid-segments because they connect the midpoints. And we learned that the ones that are parallel to each other are also congruent. So BC is going to be the same length as those two pieces in green. AC is going to be the same length as the blue ones. And AB is the same length as the red ones. So what piece do they give us? They give us AC. If you look at our chart, AC is listed in blue, right here. Which ones are congruent to that? That means the same size. Well, AB, that's red, nope. BC, that's green, nope. EF, that's the entire thing, EF. We don't want the entire thing, we only want half of it, so that's not going to work. EB, that looks pretty good. Notice how it's just one portion of it. And then the last one, DE. DE is not going to work either. So the choice is D, EB. Number 50. A triangle has ratios of 1 to 2 to 3. Find the value of all angles in the triangle. Here's where you might want to draw a quick little sketch. Doesn't have to be correct. We know that the ratio is 1 to 2 to 3, but we don't know what they are. If the ratio is 1 to 2 to 3, then we can say that as 1x to 2x to 3x. 1x to 2x to 3x. From this point, we know that there are 180 degrees in the triangle. So 180 has to equal all the measures inside. So it will be 1x plus 2x plus 3x. We can combine our like terms since they're on the same side of the equation. 1 plus 2 plus 3 is 6, so I get 6x. Divide both sides by 6, and I get x equals 30. Now, if you look over at your answers, that's not the choice. It says find the value of all angles. So to find the value of all angles, we take this 30 and we plug it in. 30 times 1 is going to give me 30 here. 30 times 2 is 60. And 30 times 3 is 90. Notice that this triangle would not look correct because this 90-degree angle doesn't look quite right, but that's perfectly okay. We only use it as a sketch. It didn't have to be correct. So if we look at our answer choices, D, 30, 60, 90 is our correct answer. Number 51. Use the figure at the right where point D and E are midpoints. That means that DE must be a mid-segment. And one of the theorems we learned is that the mid-segment is half the length as the third side. The third side here is BC. So that means that DE is 1/2 the third side, which is BC. It gives us DE as 8, and BC is 2x plus 4. So now all we need to do is plug those two numbers into this equation right here. So we get DE, which is 8, is equal to 1/2 times 2x plus 4. I'm going to multiply both sides times 2. If I multiply both sides times 2, the half will cancel with the 2 because you get a 2 over 2. On the left side, we'll be left with 2 times 8, which is 16, equals 2x plus 4. And from here, we simply simplify. Minus 4. So we get 12 is equal to 2x. So therefore, x equals 6. That's our correct answer, letter D. Once again, be careful. Here I asked for x, but it would be a different answer if I asked for, say, if I asked for BC. So please be careful of whether you need to plug it back in or not. The last problem, I'm going to scroll up so we get a little bit more room. (52) Use the figure at the right. Using the proportionate triangle, solve for x. Well, first thing we need to know is we need to know that this triangle is a similar triangle. We have red triangle in here, and it is similar to the green triangle because they overlap. Similar means that they're the same shape, but they're different sizes. So we can say that triangle DBE is similar to triangle ABE. That is, the small triangle is similar to the big triangle. I'm sorry, this is not ABE, it is ABC. Oops. ABC. Now we can set up, for all similar triangles, we can set up proportions. So if we look at this triangle, notice that for DE, there is no corresponding piece given for AC. So that's going to be the worthless side. The two sides I want to care about are this side and this side over here. So if we set up a proportion, we're going to go DB, small triangle, to the big one. The big triangle, the other side that matches up with that. Notice DB are the first two. It would be AB for the second triangle. Equals, if we look at the right side of my triangle, we care about BE here on the right. Notice that that matches up with BC. So it's going to be BE over BC. Next, we take our numbers and we plug them into this formula I have, or this ratio I've set up between the similar triangles. So dB, what is dB? Well, it's short of x. Notice that x is the entire length from B to A. BD here is going to be a little bit shorter than it. So if we drop it, it's how much shorter? It's 3 shorter. So the dB part is x minus 3 over AB is the x value equals BE is going to be 18. And then BC, notice, is the entire piece. So it's going to be 18 plus 6. So it will be 24. From here, whenever you have fractions and there's the equal sign in between, you need to cross multiply. So we cross multiply right here, we get 18x equals 24 times parentheses, x minus 3. Remember to keep them in their grouping, so if it's more than one term, remember to keep the parentheses. We simplify 1 second, 18x equals 24x minus 72. Subtract 24x from both sides. We get negative 6x equals negative 72. Don't forget about this negative sign right here. Divide both sides by negative 6. Then we get x is equal to 12. Check your answers. That is answer E. All right, number 53 here. What is the area of the triangle to the right? If we look at the triangle to the right, we know that the area of the triangle is half the base times the height. We have been given the base here. It's 24. But the height, remember, must be perpendicular to it. That is right here, which is not given. So what we need to do is find that height. We do that by breaking this up into 2 smaller triangles. Here's one outlined in red. We have the 13, and we have half of the bottom. Well, half of 24 means that this piece has to be 12. We know that this is also a right angle, so we can use the Pythagorean Theorem. So we can say that a squared plus b squared equals c squared. Remember that c squared is always your longest side, the hypotenuse. So this is 12 squared plus x squared equals 13 squared. I'm not going to spend the time to do this, but this turns out so that x equals 5. So we can replace my height now. Instead of the x, we can write it as 5. Oops, let's just erase the whole red triangle, actually. We know that the height is 5 now. So if we go back to my formula I wrote over on the left, the area is 1/2 the base. We're back to the whole triangle now. So we want the entire triangle. The base is 24. The height is 5. Half of 24 is 12, so it's 12 times 5. 12 times 5 is 60. Remember, units, we're looking for an area. So the units are meters squared. That is answer B. Number 54, what is always true about parallel lines? That answer comes from chapter 3, I believe. We know that parallel lines, they are equivalent. Letter C, that doesn't really make sense. Their slopes are opposite reciprocals. That's actually true for perpendicular lines. So that's not going to work for parallel. Their slopes are always positive. That's not necessarily true. For example, I can draw 2 lines that are parallel, but they're heading down and to the right, so those slopes are negative. That's not going to work. They have the same slope, maybe, or they have the same y-intercept. Well, let's take a look. We got to draw 2 different pictures. So I'll set up 2 graphs. This is for A, this is for B. A is they have the same y-intercept. The y-intercept is where they cross the axis. So where they cross the axis, I could have this, but if it has to hit at the same point, the other line would be something like that. I missed a little bit, but you understand. The other line would be like that. Clearly, those are not parallel. The last one is the same slope. This one goes up at a constant rate, goes up and over. The one that's parallel to it is going to go up and over the same amount. So they have exactly the same slope, the letter B. Number 55, what is the value of y? Notice that right away, this is a 30, 60, 90 triangle. This is one of our special right triangles. You will have this on the test, 30, 60, 90. Remember that the short side is x, the hypotenuse is 2x, and the long side is x root 3. So right away we can figure this out. We can say that the answer here, we notice that they've given us the hypotenuse. The hypotenuse they've shown us is 8. If we know the hypotenuse, we just need to take half of it because we need to go from 2x to x. So therefore the answer must be 4. Another way to do that problem, if you wanted.
Ms. Joyner, please dial extension 100. Ms. Joyner, please dial extension 100.
Another way to do that problem, if you wanted, would have been to use trigonometry. Remember that this would have been 60 degrees. Oops, sorry. Second. This would have been 60 degrees. If that's 60 degrees, we need to label the other side. This would be the opposite, the adjacent, and the hypotenuse. Remember, it's SOHCAHTOA. Be sure you know how to spell that. SOHCAHTOA. The parts that we care about, we're given the 8. We want to find the y. So that's the hypotenuse and the adjacent. Hypotenuse is here and here. Adjacent is here and here. So which one do we need to use? We need to use the cosine. If you want to set it up, you would say that the cosine of 60 degrees is equal to, this is in order, adjacent over hypotenuse. So it's going to be y over 8. And then from here you simply put this over 1. You have two ratios with the equal in between them, so you cross multiply. You get 8 cosine 60 degrees equals y. You go ahead and type that into your calculator. Make sure it is in degree mode. Make sure that your calculator is in degree mode before you type that in. If you do that way, you'll also get A. Moving on to number 56. A right triangle, key piece of information, right triangle. A right triangle has side lengths of 5, 12, and x. Draw a triangle. It says the unknown side is the hypotenuse, so that's going to be x. The other ones have to be 5 and 12. Find the length. Well, this one's pretty easy. It's just the Pythagorean Theorem. A squared plus b squared equals c squared. You get 5 squared plus 12 squared equals x squared. Dot, dot, dot. You figure it out. The answer is going to be 13.0. What is the measure of angle A to the nearest degree?
Ms. Joyner, please dial extension 100. Ms. Joyner, please dial extension 100.
What is the measure of angle A to the nearest degree? Notice that this is going to be another trig problem. We don't have enough to use the Pythagorean Theorem. Well, we do, but it wouldn't find the right piece. It would find us the side. We want the angle this time. So let's look. Mark the angle. Label the sides. This is my hypotenuse. This is the opposite side, since it's furthest away. And the last side is the adjacent. Which sides have we been given? We've been given the opposite, and we've been given the hypotenuse. So if I remember SOHCAHTOA, you can see it right away. The one that has the opposite and the hypotenuse is the sine. Notice it has both opposite and hypotenuse. So we plug in our values. We say sine of, well, usually the angle goes in there in degrees, but we don't know what it is. So sine of angle A equals the opposite over the hypotenuse, so it's 10 over 18. Now, we learned about inverse sines. So this is where we need to use the inverse trig functions. Inverse trig. We use inverse trig to find angles. And that's the only case. Here we want to find the angle, so we need to take the inverse. On the calculator, they're located right above your sine, cosine, and trig functions. So to find that, we say angle A is equal to the inverse sine, so sine to the negative first, And the part that was on the right side of your equation now moves into the parentheses, so 10 over 18. If you type that into a calculator, you will get C, oh, I'm sorry, not C, wrong problem. You will get B, 34 degrees, to the nearest degree. You'll have to round a little bit. 58, what is the total sum of the interior angles? So sum of the interior angles of a pentagon. Pentagon, remember, means 5, so there are 5 sides. We had a formula for the sum of the interior angles. That formula was n minus 2 times 180. Where did that come from? You may remember we did an activity where we had pentagons, and we had to draw the diagonals. How many triangles do you see? I see 1, 2, 3. Okay, I'll come back to that in a second. So the formula, n is the number of sides, so we plug it in. So it's 5 minus 2 times 180. 5 minus 2 gives you 3. 3 times 180 is 540. Answer is D. What does that picture have to do with it? Remember that each triangle is 180. So if I have 1, 2, 3 triangles, and each one of them is 180, altogether, they're going to be 540. So you can think of this either way. You can either use the formula, or if you're stuck, you can draw the picture and draw the diagonal. Number 59. What is the value of x? Notice that these are no longer interior angles, they are now exterior angles. Exterior are on the outside of your shapes. Remember that exterior angles always add up to 360. I shouldn't say equal, I should say sum to. So exterior angles sum to 360. So all we need to do is add up all the pieces around and set it equal to 360. So 2 plus 2 plus 3 plus 4 plus 4 plus 5 turns out to be 20. So 20x, all of them together, equals 360. Just simply divide both sides to get x equals 18. Letter D. Number 60, find the height of a triangle.
Attention teachers, the meeting with Francisco Bonilla's mom is going to start now. Thank you.
Number 60, find the height of a triangle with a base of 10 and the area of 230. So the height of my triangle, draw a quick little picture. It says the base is 10. The height, we don't know. But we do know that the area is 230. So this is a case where we just do the formula kind of in reverse. We know it's a triangle, so the area of a triangle is 1/2 the base times the height. Plug in your area, it's 230 equals half the base. Well, the base is 10 times the height, which we don't know. Half of 10 is 5, so 230 equals 5h. Divide both sides by 5, and you get that h is equal to 46 centimeters. That is choice is B. Number 61. Find the length of PQ. Talking here about the arc length of PQ, which is like the crust of the pizza. To the nearest hundredth, that means 2 decimal points. So the length of PQ, we plug it in, it's the arc length is equal to the arc measure over 360 times 2 pi r. Notice that it's 2 pi r because this is kind of like a part of the circumference. It's just a piece of the circumference. We plug in our values. The arc length is equal to the arc measure, which is 110 over 360 times 2 pi times r. Well, r here is the radius, which is 4 inches. We reduce. The arc length is equal to, this reduces to 11 over 36 times 2 times 4 is 8, so 8 pi. At this point, we need to multiply these two together, so put it over 1, so you can multiply them together. Here, there is no equal sign in the middle, so we multiply top times top, bottom times bottom. Top times top, 11 times 8 is going to be 88 pi. The bottom is going to give me 36. We can reduce that, divide both by 2. We get 44 pi over 18. We can reduce by 2 again. So we get 22 pi over 9, and at that point we're stuck. You got to go to your calculator, type those numbers in, your answer comes out to be approximately 7.68. Number 62. A triangle has side lengths of 6, 12, and 15. Is the triangle acute, right, or obtuse? This is where we need to use the Pythagorean Theorem, but it's going to be the opposite because we don't know that it's right yet. So we can't say that a squared plus b squared equals c squared because we don't know. It doesn't tell us that it's right. So we have to put the blank mark. Now you'll have to spend some time memorizing this, but when we solve it, it will tell us what it is. First off, even before you start, this triangle cannot exist with the given lengths. Well, yes, it can. And D, is it a straight triangle? Such thing doesn't exist. So there's really only three choices. Plug in your values. 6 squared plus 12 squared blank 15 squared. 6 squared, you get 36 plus 144 blank 225. This becomes 180. This is 225. Fill in your blank. It's going to be 180 is less than 225. Whenever your C value is bigger, it's going to be obtuse. That's the way I like to think of it. C is big, angle is big. Big angles are obtuse. The opposite, if C is small, so if it's less than 80, or 180, then the angle is small. The 180 here has nothing to do with 180 degrees, it just happens to be a coincidence. This is an obtuse angle. The last one talks about the ratio of, excuse me, whoops, didn't mean to do that. The last one here talks about the ratio between the two pentagons. It says that they're similar. Once again, that means they're the same shape, but they're not the same lengths to each other. So to solve this one, we need to set up a ratio. If we're looking at the ratio of the side lengths, the ratio of the side lengths is going to be 10 to 16. 10 to 16, we can reduce that if we divide both by 2, so it's going to be 5 by 6. We want to find the area ratio. Well, to get to the area ratio, we need to square the side ratio. Remember that area is always units squared. That's what you can remember. So 5/6, we need to square. I'm sorry, did I do that correct? This should not be 6, it should be 8. Sorry about that. That's 5/8. We need to square. So that becomes 25 over 64. Now, 25 here is my small pentagon. And it tells me that the area of the small one is 75. So I need to take this information and put it into a proportion with this area ratio right here. So small to big is 25 to 64 equals, we know that the small one is 75, but we have no idea what the big one is, so we plug in an x. Here we go again, proportion. We need to cross multiply. So we get 25x equals 64 times 75. That will come up to 4,800. 4800. Divide both sides by 25. You get that x is equal to 192. Don't forget the units. We're finding the area. So it's going to be feet squared. 192 feet squared is answer D. Alright, that's all for the multiple choice. I'm going to make a different video for the free response. If you have any questions with any of these, feel free to contact me at a later time or email me or whatever you need to do to get this figured out. Good luck, everybody.